Okay, awesome. So I think this is everyone. So thank you all again so much for coming, and let's get started. So first of all, I am going to be sending you all the link to my GitHub. Um, and this repository contains the material needed for our workshop today. So we're going to be covering mostly intro to supervised machine learning in Python. I'm going to show you how you can use a pipeline through sklearn's packages to apply these machine learning models without actually implementing them yourself, which is a ComSci 340 level of problem. So we're going to be using other people's packages today just because this is a beginner workshop and there's no math prereq. So yeah, that being said, let's jump into it. So I'm going to send the link in the chat if it will let me. Why won't it let me? Okay. Okay, so does everyone see the link in the chat? So if everyone could click on that link, and you're going to want to download the repository or clone it. Now, if you have Jupyter locally and you have like a bunch of the mainstream packages installed, that's totally cool. But I'm assuming most of you don't. So we're going to go into Google Colab. And that's where we're going to be working today, at least you guys. Yeah, so once you download the code, you can unzip it and upload it right into Google Colab. And then after that, you are going to upload the transport CSV file. So you want to basically just open the workshop notebook into Google Colab and then the transport CSV file. All the images are basically just for my slideshow, so you don't really have to worry about that. But I'm just going to give everyone a couple minutes to do that, and then we will get started. Yeah. So maybe just put your hand up if you have questions, and then I'm just gonna create a poll, and then when you're done, you can like answer. How do I create a poll? Yeah, when you're done, you can answer the poll and say that you're done. So I know when to move on. Yeah, do you have a question, Giselle? Or did you? Oh wait, never mind. You don't have your hand up anymore.
Hi, Hannah. I'm not sure if your chat will do.
Sorry, could you repeat that? I couldn't hear you.
Oh, yeah, just the chat is active.
The chat? I don't see any. Oh, sorry, I couldn't see that. My bad. Yeah, you know what? Let me just do it. Like, I'm not actually using Google Colab myself, but let me just do it anyways. Just in case. Oh wait, actually maybe you can go to GitHub. Oh, you know what? You might even be able to just upload this right from GitHub, but I'll try the other way. Let me see. Okay. No. No. Okay, yeah, so this is it uploaded, and then can we go over here? Do we go over here? Wait, no. Okay, I think it's just connecting to something. Yeah, it's connecting. So I don't think you can, okay, and then you upload your data into this thing, into the files here. So just this transport CSV, we're just using a super basic example today, but we will be providing some fashion data sets that are a lot more complex during the hackathon. So that's exciting. Yep. So yeah, there you go. So this should be able to run. Yep. So just quick tutorial on Google Colab. So Google Colab already has all of these environments, like all of these packages that is listed here. All of this is already pre-installed. So you just upload your data and you specify what packages you're using and you're good to go. You don't have to pre-install it. That's the benefit of Google Colab. In addition, it's easy because you don't have to install anything on your machine. So I definitely recommend it if you're playing around with a data set in general or during the hackathon. Good place to start. The other thing that you could do if you're more, or if you would like to do this on your own time, is download Jupyter locally. So I'm working here in Jupyter because it gives me this nice option to do a slideshow, which is another extension that you can install. But yeah. Okay, so I think everyone, it looks like, and yes, the recording is going to be posted on our YouTube channel. So no worries if anyone can't stay for the whole time. So I think we'll get started because the Google Colab thing isn't super hard. Yeah, so welcome to girlCode's Intro to Machine Learning in Python workshop. We're super excited to have you all here, and yeah, let's get into it. And also big shout out to our sponsor Aritzia for making this possible. They have been very integral in planning this hackathon with us and have dedicated a lot of time and resources towards the hackathon, not just money like most companies do for hackathons, but also have spent like hours upon hours of time to plan it. So major shout out to them. And yeah. Ooh, let me run this. Okay. So first of all, let's jump right into it. So what even is supervised machine learning? So essentially in supervised machine learning, you have your training data, and so you have a set of observations and you have corresponding targets. So real quick example, because this is kind of abstract. Let's say you have a bunch of features in a house. You have square footage, you have lot size, you have location, you have number of bedrooms, etc. And you want to predict the price of the house that it's going to sell for, or how much it's worth. So your observations, the X, capital X, would be all those features that I just previously listed. So lot size, location, whatever, number of bedrooms, etc., age of the house, etc. The targets would be the price. So that's Y. And so your data is going to look like each row, you're going to have like your observations, and then you'll have your target at the end of the row. And so you're going to use all those observations to predict the target. So yeah, so our goal is to learn a function that relates X to Y, and then we can use it on the key thing in real life is unseen examples. Okay, cool. Yeah, so this is just a little diagram that kind of makes it make more sense. So we have our training data, have our learning algorithm, learned function that the algorithm will learn. And then we have our unseen data and we want to predict, is this a cat or a dog? And so hopefully if our model learns well, it will predict cat and dog. Okay. So yeah, this is just a little bit of background. So where do we see machine learning in the real world? Everywhere. Hint, hint, literally everywhere. In your Starbucks app. What is Starbucks? Like Starbucks is giving you extra rewards, trying to make you spend more money. Yep, that's the machine learning algorithm. Uber Eats, the price surging in Uber, that's the machine learning algorithm. A recommendation system on Amazon. Oh, you should buy this book because we see you have been searching these type of topics, or we see you like this type of book. Okay, maybe you would like this book. That's all machine learning. Face recognition, voice assistance, breast cancer tumor prediction, everything. So it's definitely a very useful area to go into because it is used everywhere and in every industry and every type of company. So yeah, and also just so you know, if you have any questions, just put your hand up quickly. Or yeah, put your hand up and I will get to them. Okay, so first, so I guess maybe I should tell everyone how the workshop's going to go. So I have some background theory that I'm going to cover, and then we're going to get into some hands-on coding examples. And these you can apply to kind of any data set, and so you can kind of copy paste this code and use it however you'd like. Yeah. So first, background theory. So I want to quickly talk about the fundamental bias variance trade-off. So what that is essentially like in a perfect world, we would have low bias and low variance. So what bias is it's essentially how well the model matches the training, or the model structure matches the training set. And variance is like how much the model changes from a small data set used when you generalize that to the entire world or population, etc. Because remember, we only have a certain size of training data that we can use to build our model. But the world, there might be way more, like triple, quadruple, 10 times more. So there's a lot of variation that might occur. So high bias model and low variance tends to underfit. And underfitting is and overfitting is terms that you'll hear frequently in like machine learning. So low bias, high variance is overfitting. So certain models such as decision trees, they tend to overfit. We'll look at that a little bit later on. Certain models like logistic regression, they tend to underfit the data. So in other words, like overfitting is essentially like the data is picking up on like way too many things, or sorry, not the data, the machine learning model is picking up on way too many like small variations in the training data. And what happens is you get a very high score of accuracy on your test set, on your training set, but it does not translate well to unseen data because the model's picking up on these little nuances that are only in the training data set and not actually in the general population. Underfitting is kind of the opposite, where the model it doesn't pick up on enough stuff, and then it just has lower accuracy in general. So that's also bad. Yeah, so you can kind of see it in this diagram here. Okay, cool. So next bit of theory before we get to the coding is cross-validation. So what is cross-validation used for? So it's mostly used, most people use it for hyperparameter optimization. So we're going to be talking about hyperparameter optimization a little bit later. So no worries if you don't know what it is now. And it can reduce overfitting. So overfitting, as mentioned before, occurs when we test our model and it works very well on the training set, but does poorly on real world data. So there's a lot of different types of cross-validation. The one that's like usually used is k-fold. That's pretty standard. Yeah, so holdout method, leave one out. Those are two, we won't really be covering them. And then k-fold is the one that's most commonly used. If any of you have taken like Data Science 100, I'm actually a TA for that course, you would have maybe learned about that here as well. So essentially, basically what cross-validation is you're just taking the training data set and you're breaking it into chunks, and each chunk you break into a validation set, and then you're just continuously like training the model on that chunk of data, and then you can like compare the score, and it uses like each different part of the data set, so you get like a more accurate result. Yeah, and then the other type is like stratified cross-validation, and it's good for class imbalance. But we won't really be looking much at that here. Okay, awesome. So next up, on a little bit of background theory that's super important, and this is like the biggest rule in machine learning, like the golden rule. You can never mix your test set with your training data. You never, ever, 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 ever want to train your model with anything that is influenced by the testing data set, because that means that you won't be able to actually tell how well the model generalizes to new data. And in terms of machine learning, we're not doing a data analysis. We're not necessarily trying to understand the data we have. That's totally different. And that is like data modeling is like oftentimes people do data modeling as well. But in machine learning, our goal is to be able to predict on unseen data and unseen examples. So that's why it's super key to always isolate our training data set. And we'll go into how we do this in Python code, and we'll be following a very simple pipeline to ensure that this is always the case. Yeah, okay, so let's look at some code. So you guys can follow along on your worksheet. All of this slideshow is literally just the notebook that you opened in Colab. So feel free to follow along on your own computer. So first of all, we're gonna read the data set in using the pandas function. So I'm assuming everyone's heard of pandas, but if you haven't, pandas is a really good package in Python for data analysis and data cleaning and data wrangling. So we're gonna use its nice little read CSV function to read in the data, and then we're gonna drop the date column. And the only reason I'm dropping the date column is because we're not doing time series analysis here, so it's not really useful for us. Okay, so there we go. You know what, hold up, I'm gonna restart the kernel so everything runs instead of it being all loaded. So just give me a second. Okay, so next step is we're going to be splitting our data set into the train and test set. So this is really key, so we're not breaking our rule of machine learning. So essentially what we're doing is we're taking a data set and we're going to put 80% of that data into the training data set. And we're going to use that to train the model. We're going to take the remaining 20% and we're going to save that for later. And that is how we're going to be able to compute an accuracy score on our model. And we're going to be able to see like how well is this model doing on unseen data. So you can see this hyperparameter test size. That is just specifying like what percentage you want in the test set. So industry standard is like an 80-20 split, 75-25, maybe 70-30 if you have a huge data set. But anything in that realm is perfectly fine. And this function is from like sklearn. So we imported that earlier. So yeah, and so what we're doing here is we're dropping the mode column. So that's what we're going to be predicting. So that's our Y target. And then our Y target is going to be mode, and then our X is just going to be the other columns without that. So that's essentially that's the syntax. So my recommendation would be search up pandas cheat sheet, because it's gonna basically show you how to do all of these little things. Syntax here is pretty straightforward, but I would still recommend, like, especially when you're at the hackathon, if you're trying to do machine learning and you're a beginner, definitely like search up pandas cheat sheet, search up like sklearn cheat sheet. I'll actually post some resources in the workshop channel after this as well that you can look at in preparation. but yeah, always good to have that. Okay, yeah, and then here we're basically just doing the same thing for our X test and Y test. So we're just dropping the column again, and yeah. So you might be asking, like, what even is in X train? So, I mean, we could print that out to show you. Yeah, so you can see that like the mode column was deleted and we just have the other column. So we have route, we have week, and we have ticket price. So we're going to use these three features to predict mode of transportation. So I think it's like train versus plane. And you will see here that the model is going to be super accurate here. And we'll talk about that later in a second. But yeah. Okay, so now let's look at the data set information. So this is a little bit of an exploratory data analysis. It's always super important to know like what your data is. So this is the syntax to just look at the first, like, I think 5 columns of the data set. Otherwise, like, we don't want to print out the entire data set, right? That's too much. So we just usually look at the first couple column or first couple rows, sorry. So yeah, we're printing that out here. And yeah, that's the syntax to do that, just for your future reference. And then right here, we want to see what types of routes there are. So we have, so this is a data set about traveling in like India, I think. So we have like a couple different routes, Mumbai to Delhi. I'm gonna butcher all this pronunciation, so I'm just not even gonna bother saying it, but you get the gist. So these are just the different types of routes. So this is called a categorical variable. So that just means that it's like text data, and we're gonna have to somehow encode it. So we'll get to that in a second. Oh yeah, okay, here we go. So we need to transform it somehow into dummy variables. So essentially you're going to have, so the number of dummy variables is the categories, number of categories minus 1. And it's going to be encoded into like a 1-0 type of situation. So essentially the reason why we only need 5, or how many do we have here? We have 6. So we only need 5 dummy variables is because if every single column, like new column that we create is 0, that just means that, oh, it must be the 6 option if everyone's 0. So yeah, let me just figure out how to do this whiteboard situation. Oh, I can just annotate on Zoom actually. Okay. So essentially, like, we might have like, let's just say this is a, okay, so we're gonna create like 5 new columns. And each of these columns is gonna be like A, B, C, D, E. Now, let's say in our observation, so we're looking at one data point. Let's say the person went from Mumbai to Delhi. That means that in every single column, it's going to be a 0, except there's going to be a 1 in the C column. So then that's how the algorithm is going to know, okay, this person went from Mumbai to Delhi. If the person was in, let's say A, then it would be a 1, 0, 0, 0, 0. You guys get the gist. Yeah, so next, how can we do this in Python? So we can use a column transformer. So the nice thing about the column transformer is that it's super easy to use and other people have already coded it for you. So you just got to apply it. So let's take a look at that. So first of all, we want to specify the columns we want to transform. So we're going to separate this into numeric because we're going to apply scaling to the numeric columns. Why do we scale? Well, we want to standardize our data. We want everything on the same scale so that the machine learning algorithm doesn't like favor one column over the other. We're going to specify route as our categorical feature, and we'll run this. And next step, we're going to use sklearn's column transformer to apply transformations to each column. So this is just the syntax, and you can use this on any other data set as well, as long as you're specifying the correct columns. So feel free to copy paste this if you need it in the future. So we're going to be applying one hot encoding, and that is what I talked about before with the dummy variables. And it's going to do that for you. Instead of you having to do that manually, it's just going to do it all for you, nice and easy. And then for the numeric features, we're just going to apply standard scalar. So again, this is the function that you can use on any numeric column in any data set, essentially. So let's run that. And now we're ready to train our model. So how are we going to ensure that the column transformation are applied without any info from the test set leaking into the model? So we're going to be using a pipeline. This is a really nice feature of sklearn. And so today we're going to be looking at the first model, at least we're going to be looking at, is logistic regression. So after you make the pipeline, you can call fit on it and build the model. So we'll look at that a bit later, but let's just look at making the pipeline first. So here's the syntax of making the pipeline. So we just call it pipe underscore logistic regression. We're going to go make pipeline. That's the function that we're calling. And we're going to specify the column transformer that we made a couple slides back. And then we're going to specify the model we want to use. So if you wanted to use a different model, and we'll get to this later, you could just replace this logistic regression with another machine learning model. So yeah, so it's very easy syntax. You can use a bunch of different models with this syntax as well. So that's super nice. So let's run that. And let's just talk quickly about what even is logistic regression. Many of you guys might not have heard of that before. So our goal here is we want to determine whether someone took a plane or a train. And so we can use logistic regression for classification problems like this. And so we're using training data to learn coefficients, which then can be used to calculate a prediction probability. So I'm not going to go into the math of it here, but this is the function that is used to do this. If you want more information on logistic regression, I would recommend, I'd say stat 306 or stat 301. And so what are some pros? Like, why would we use logistic regression over, let's say, a neural network? Well, the biggest thing about logistic regression is it's really easy to interpret. And sometimes that's necessary if you're solving like a business problem or something that you need to be able to explain to stakeholders. Like you need to be able to interpret it. They might not know, or you might not even know what the neural network is doing. So with logistic regression, we at least can easily interpret it. Sorry, there's like a typo here, but oh wait, no, that's, I don't know why it's cut off a little bit. Sorry about that. But essentially the coefficients give us info about feature importance and direction. So typically larger, more important, and then you also have the magnitude like negative and positive. It's also low variance, so it's less likely to overfit. And obviously we don't want to overfit. So we can accurately use like the validation set scores and not be so worried about it overfitting, which is nice. Okay, cool. So next, before we get back to actually fitting the model, let's do some hyperparameter optimization. So hyperparameter optimization is essentially hyperparameters are used to tune our model during learning. So there's various models will have various hyperparameters. And logistic regression has a hyperparameter called C, which is used to control our fundamental bias variance trade-off that we talked about earlier. And it can reduce the likeliness of the model either over or underfitting. And so, yeah, larger values of C increase the chance of overfitting, and then smaller decreases, or sorry, smaller increases underfitting. So let's try to optimize the hyperparameter C. So this code is something that I wrote to optimize the hyperparameter. So feel free to reuse this in the future. So for those of you that maybe are beginners, maybe I'll walk through like what even is this code doing. You might be looking at this and thinking what. So we have a empty array here with train scores and CV scores. So this is our cross-validation scores. This is essentially just going to give us some random values. It's going to give us like a bunch of values for C to test. And basically you can just search up like what are industry standard values to tune hyperparameters with like logistic regression or with random forest or whatever, and get kind of like a range of values that you might want to try. And so these values are going to be stored in like an array. So then what we're saying is we're going to loop through our array of values. So let's say the first value is 10, then we're just plugging 10 in there. We are making the pipeline and we're specifying. So now in logistic regression, we're now adding another parameter and we're going to add the hyperparameter in there. Then for our results, we're going to use cross-validation to essentially calculate a validation score and see which hyperparameter we even want to use. So let's do that here. And then we're just, at the end, we're just putting all these scores into a data frame. Okay, so it kind of got cut off. So let me just, yeah, okay. So there you can see. So all of the scores are 1. Why are all the scores 1? It's actually just because this data set is very easy for the machine learning model to pick up on. Realistically, though, you wouldn't have all the scores being 1. You'd have the scores being less than 1. And that's like super normal. So if you get a score of like 80% and you're like, oh no, 80%, 80% is actually good. Especially for logistic regression. Okay, let me just go back to view. Okay. Okay, cool. So now let's fit our model. So we've picked our hyperparameter. So maybe I'll just like list the steps. So we split into the test training. We do any data pre-processing. So that's applying the column transformers. We create our pipeline in hyperparameter optimization, and we're going to optimize the hyperparameter, and we're going to pick one. So we pick the highest value here. It can be anything just because this data set is very easy. But in general, you will have a hyperparameter, that value that wins. And then now with all this information, we're going to actually fit the model. We're going to plug all of this into the model. So we're using c = 1. And then this is the key part down here, model.fit. That is the function that you're going to use to fit your model. So you're going to fit it on the X train. So you're going to specify like the feature columns in the training data set, and then the Y train, which is just the row of targets. So let's fit our model. And so it's just going to input the steps that it's doing. So we see that it's applying our column transformer and the logistic regression model, etc. You can kind of just ignore that though. Okay, so after fitting the model, we're going to predict on the test set, and then we're going to print out our accuracy. So, accuracy is a common score used. It can do a good job. It's not always used as a metric though. And to be honest, especially in terms of class imbalance, accuracy is not usually used. And so we'll look at a different metric in a couple minutes to see if we did have class imbalance, what should we use in that case? But yeah, let's run this. So our accuracy is 100%. Now, why is our accuracy 100%? It's because the price tickets for train is so much lower than airplane that the model picks up every time, like, oh, we're spending over like $2,000. Oh, it must be an airplane. So that is why this is doing so well. In most cases, though, it's not going to do this well. So don't be like upset if your model isn't giving you 100% accuracy, especially with logistic regression, because that's usually not possible. Yeah. So I'm going to talk a little bit now about ROC curve and area under the curve. And this is a really good metric to use if you have class imbalance. So what even is class imbalance? Maybe we should talk about that first. Let's say you are a credit card company and you want to predict the number of clients that are going to, or you want to know which clients are going to likely default on their credit card next month. Well, most people pay, right? Most people pay on time. You're going to have a very large number of clients or customers who are paying on time. You're going to have a very small number of customers who don't pay on time. So you might have something like 90% of the data that you're using to build your model is going to be class 1, which is they don't default. You might have only 10% of observations that are the other class. So when you calculate accuracy, it's going to give you 90% accuracy as a base accuracy, because the model literally, if you predicted 1 every single time, you would get 90% of that right. So we need to use other metrics in this scenario to distinguish how well is this model actually doing. So ROC, and specifically area under the ROC curve, is a really good metric to use in that scenario. So essentially, it's just the false positive rate versus the true positive rate. So a perfect classifier would be up here, and then a random is just down the middle. And like a good one might be the blue line. So the area under the curve, so I'm actually going to go back. So basically area under the curve is we're trying to calculate like all of this. So let's say it was the blue curve, like we're calculating the area like all under this curve. And we're going to use that, or we could use that as our metric. Yeah, okay, wait, sorry. Okay, there we go. Okay, so then, yeah, so area under the curve is essentially just like the model's ability to distinguish between the classes. So given a new observation, can the model determine, is it a plane? Is it a train? Is it a breast tumor? Is it a malignant tumor, or is it benign? Is it defaulting on the credit card, or is it not defaulting? So that type of thing. Yeah, so now we're going to look at the ROC score here. So it is giving us a score of 1, so that's very good. Essentially, this data set is honestly too easy for the model, but it's just a simple data set to use, so that's why I picked it. Yeah, okay, so next we're going to be looking at a plot of the ROC curve. So yeah, we can see it's 1. So oftentimes people like to plot the ROC curve. Feel free to like reuse this code if you ever want to make one. Yeah, you're just taking like the logistic regression probability, your test set, and this is using MATLAB. So if you do a quick Google search, like MATLAB cheat sheet, super simple syntax, super easy. You can just copy and paste. So yeah, let's look at a little example now. So here is our example. So this is our little observation, and then we can get our predicted probability like this. So what it's telling us here is that it's predicting 100% that it's plane. So if it was 80% sure that it was a plane, then this 1 would be replaced with like 0.8, and this 0 would be replaced with 0.2. So we can also look at the hard prediction using this, and so then we can get the plane. So yeah, so this is the threshold. So our threshold right now is 0.5. You can change the threshold though, if you want. So maybe we're predicting tumors and you want to be like super sure if a tumor is actually cancerous, or let's say like you want to be less sure if it's cancerous because you want someone to go to additional screening. So, and you'd rather someone go to additional screening and then find out they don't have cancer than not go and have cancer. So you might set that threshold to be like 0.3, and anything over 0.3, it's predicted as potential tumor or something. Okay, cool. So we're going to look at what is a decision tree next. So this is another type of machine learning algorithm. And essentially it's a classification model that predicts the value of a target based on simple learning rules that it learns from the data. So I'm going to show you an example that will make more sense. So this is essentially decision tree. You guys have probably seen them. You may have made them before, but the machine learning algorithm, this is an actual machine learning algorithm, which is kind of cool. So yeah, so you might start with income, and then you're you go down to age and then it splits it. Okay, is this person old or are they young? Are they a student? Are they not a student, etc. And it learns the essential decision tree. And then when it goes to make a probability, or when it goes to make a prediction, it kind of follows through that decision tree and then makes the prediction. So pros, simple to understand, again, easy to visualize, especially using in cases like a business. Super easy to understand and visualize there. Cons is it is very, very, very prone to overfitting, like highly, highly prone. So we can combat that though with hyperparameter optimization, if necessary. So how can we build this in Python? So literally, this is why I love sklearn. Exact same code as earlier. All you do is replace logistic regression with our decision tree classifier. And you can essentially do this with any algorithm that's in sklearn. Yeah, you can even, like, I can even Google it and show you guys. Okay, sorry, my computer is like crashing. Why is this? Okay, you know what? Actually, never mind. Basically, what I would recommend is just searching up sklearn cheat sheet or sklearn documentation, and you can get a whole list of all these other models, like random forest, linear regression, k-nearest neighbors, all of that stuff can be used. Even more complex ones like support vectors and like XGBolt, that type of stuff. Complex. We're not really going to go over that here, but can be used in this. So that is the benefit of using these simple packages. So we're going to fit the model again, same syntax. Oh, and we can even use the same column transformer that we already specified. So we don't even have to redo the column transformer. Super nice. So we're going to print the accuracy again. We're predicting now using our decision tree model. We're getting 100% again. In real life, this is unrealistic to get this high of a value, especially for these type of models. Neural network, you might be able to get like 99% accuracy on a complex data set, but not on these models. Okay, so I guess next up, we have our random forest classifier. So I did have another example and another data set, but it looks like we ran out of time. So I think what I'm going to do is you guys can just go through the rest of it on your own. It just dives into how does the algorithm work, and we're loading a new data set this time, but you don't even have to import it. It's already built in. And then we again are using we're just creating a classifier. Here we didn't even put it in the pipeline since we're not using any scaling or anything, but because I'm pretty sure it's actually already scaled in this data set. But I would recommend following So if you're doing this in the hackathon or just in general, I would recommend following this syntax where you create your pipeline with your column transformer, because most data sets you are going to have to transform the column. So yeah, I guess that's kind of it. Does anyone have any questions about, I guess, this material, or any questions about the hackathon in general? And I can answer it right now. You can just like put your hand up. Actually, maybe I'll stop recording first. How do I do that?